We are just continuing your previous chapter and we are starting a topic, prime number. So what is a prime number? A natural number greater than 1 is called a prime number if its only factors are 1 and the number itself. So if a number is having only two factors, that is 1 and the number itself, then the number is called your prime number. Okay, for example 2, 3, 5, 7, 11, 13 and so on. So these all are prime numbers. Why they are prime numbers? Because they have only two factors. One is 1 and the other is the number itself. Okay. Next is your composite number. A natural number is called a composite number if it has more than two different factors. So if a number is having more than two different factors, then the number is called your composite number. So for example 4, 6, 8, 9, 10, 12 and so on. These all are your composite numbers. Why they are composite number? Because for let us take example of 4. So when you write down the factors of 4, so 4 factors are 1, 2 and 4. Okay, these all are factors of 4. So you can see 4 is having more than two different factors. So this is a composite number. Now next is your prime factorization. So what is prime factorization? When you break or when you write a composite number as a product of prime numbers, then it is called prime factorization. So how you do a prime factorization? Your first method is prime factorization method. Okay. So I have taken a number over here 24 and it is a composite number as it is having more than two different factors. So I have break this 24 as 2 into 12. Okay. 2 is a prime number, but 12 is a prime number? No. Very good. So as 12 is not a prime number, so I have break this 12 as 2 6 are 12. Okay. Now you can see in this row we are having 2 as a prime number. This is also a prime number. But 6 is a prime number? No. 6 is not a prime number. So I have break this 6 as 2 into 3. Now you can see in this third row you are getting all the prime numbers over here. Okay, all the numbers over here are prime. 2 into 2 into 2 into 3. So they all are prime. So the prime factorization of 24 is 2 into 2 into 2 into 3. It means you have to use only prime numbers. Second example is your 70 and the prime factorization of 70 is 2 into 5 into 7. 2 5s are 10 and 10 sevens are 70. Very good. So this is the prime factorization method in which you write a composite number as a product of prime numbers. Okay. Next method is your factor tree method. Now what you have to do in this factor tree method, I have taken one example of 60. You can break 60 as 10 6 are 60. Okay. So I have break this 60 as 10 6 are 60. Now neither 10 nor the 6 is prime number. It means I have to break this 10 also and this 6 also. So I have break this 10 as 2 5s are 10 and this 6 as 3 2s are 6. Okay, now you can see in this line 2, 5, 3, 2 all are prime numbers and they cannot I cannot break them. Okay, so the prime factorization of 60 is 2 into 5 into 3 into 2. Okay, I have written here 2 into 5 into 3 into 2. Clear? Now one more thing is there. It is not necessary to break this 60 as 10 into 6. Many of you can break it as 4 into 15 or 30 into 2. Okay, so it is up to you. So here I have done breaking the 60 as 4 into 15. Now again 4 is not a prime number, 15 is not a prime number. So I have break this 4 as 2 2s are 4 and 15 as 3 5s are 15. Clear? Again in this row 2, 2, 3, 5 these all are prime numbers. So I have written the prime factorization of 60 as 2 into 2 into 3 into 5. As you can see in both these cases, okay, in this one also and in this one also, the prime numbers which I am getting over here or the prime factorization of 60 which I am getting is same. As in multiplication, A into B is equals to B into A. So if you write, it doesn't make any change if you write this 2 over here and 2 here, and you're writing these 2 here. Okay, your answer will be 60 only. The next method is the division method. So you have to do the prime factorization of 2904 by division method. For this you have to write the number which is to be factorized over here. Okay, and let's start its division. So as you can see, the last digit is 4. So this number is divisible by 2. So I have done 2 ones are 2, then 2 fours are 8. Okay, carry goes 1, 2 fives are 10, and this is 4, 2 twos are 4. Clear? Now next line is 2 sevens are 14, 2 twos are 4, this is 5, so it will give carry over here, it become 12, and 2 6 are 12. Clear? Now third line, 2 threes are 6, it is 7, it will give carry, this will become your 12, so 2 6 are 12 and 2 threes are 6. Clear? Now 3 ones are 3, 3 twos are 6, and 3 ones are 3. Now it is 121, and 121 goes in table of 11. So 11 11s are 121. Clear? So the prime factorization of 2904 become 2 into 2 into 2 into 3 into 11 into 11. Why I have stopped over here? Because 11 is a prime number. Okay. So this is the division method of prime factorization. So we are starting your highest common factor. We have done with your prime factorization, and today we are doing highest common factor or HCF. HCF is the greatest number from the common factors of the given number. So what is HCF? For finding the HCF, you have to write down the factors of a number, and then you have to find out the greatest common factor. There are two methods of doing an HCF. One is your prime factorization method, and another one is your division method. So let's start. So here I have done prime factorization method. Okay, so your first question is find the HCF of 28 and 36. So for doing this, you have to write down the 28, and I have done the prime factorization of 28. 2 14s are 28. I told you for doing the prime factorization, you only have to use the prime numbers and start with the smallest. Okay, so 2 14s are 28, then 2 7s are 14, and 7 1s are 7. So the prime factors of 28 is 2 into 2 into 7. Now we have done the prime factorization of 36 is 2 18s are 36, 2 9s are 18, 3 3s are 9, and 3 1s are 3. Okay, so the prime factorization of 36 is 2 into 2 into 3 into 3. So as I told you that HCF is the greatest common factor. So you can see what is the common factor here, 2, again here 2. So how many times we are getting 2? 2 times. So the HCF of 28 and 36 is 2. These two make one pair, and I have written over here, and these two make one pair, and I have written over here. Then 2 2s are 4. So the HCF of 28 and 36 is 4. Clear? Next is your division method. So your question is find the HCF of 12, 18 and 46. So how you are going to find out the HCF? First you have to take the two numbers 12 and 18. Any two number you can take. Okay, so I have taken 12 and 18. Write down the greater number here. Make a box like this. Write down the greater number here and another number over here. Now 12 ones are 12. 18 minus 12 will be 6. Then again you have to make a box, and this divisor over here become your dividend. Clear? You have written this divisor over here. Now 6 2s are 12, and 12 minus 12 will be your 0. So when you got 0, this number, this divisor become your HCF. So HCF of 12 and 18 is 6. Clear? Now you have to find one more number is there, 46. So you have to find the HCF of 6 and 46. Same as we done over here, you have to write down 46 over here and 6 over here. Now 6 7s are 42. 46 minus 42 will be 4. Now again make a box and this divisor become your dividend. Okay. Now 4 ones are 4. 6 minus 4 will be 2. Okay. Again you will make a box. You have to continue it until you get a 0. Okay. So this divisor become your dividend. Now 2 2s are 4. 4 minus 4 will be 0. Okay. So now you are getting 0. So it means that HCF of 6 and 46 is 2. Okay. Therefore the HCF of 6 and 46 is 2. Now you have done the HCF of 12, 18 and 46. So you will write, hence HCF of 12, 18 and 46 is 2, because at last here what we are getting? We are getting 2. So therefore the HCF of 18, 12 and 46 is 2. Okay.